In this video, we're going to start talking about quadratic equations. Now, by a quadratic equation, we mean an equation in x that can be written in the general form ax squared plus bx plus c equals 0, where a, b, and c are all real numbers, and you want the leading coefficient a to not equal 0. This is also called a second-degree polynomial equation. Eventually, and we'll continue these in the next video as well, we're going to have 4 different methods for solving quadratic equations: factoring, extracting square roots, completing the square, and the quadratic formula. For our first method, factoring. Here we exploit the zero factor property, which we talked about in video 0.1.5. Namely, if you know a multiplication of 2 factors equals 0, then you immediately know that one of the 2 factors needs to equal 0. So how does this help us solve a quadratic equation? Well, let's go ahead and work this example. For part A, the first thing that's important here is you need to make sure before you try to solve these by factoring that there's a 0 on this side, on at least or one side of the equation. So let's bring 3 to the other side. 2x squared plus 9x plus, and if we subtract 3 from both sides, we end up with 4 on this side and a 0 there. Now, what can we do? Well, our goal here is now to try to factor this. Using the AC method, we see that 2 times 4 is 8, and we know that 8 plus 1 actually adds to give us that. So 8 has the factors 8 and 1. And so we see here, if we break this up as 2x squared plus 8x plus x plus 4 equals 0, then we can go ahead and grouping. We can pull a 2 out of these first 2 terms, 2x out of the first 2 terms. And then here we can pull a 1 out of those 2 terms. And so what we actually have here is that this is 2x plus 1 times x plus 4 equals 0. Well, now is where we exploit the zero product property, and this is why we needed 0 to be here, because now we can conclude that either 2x plus 1 equals 0 or x plus 4 equals 0. Well, solving this out, take 1 to the other side, divide both sides by 2, you get x equals negative 1/2. Or, if you solve this one out, you know that x equals negative 4 from that. Well, just to make sure, let's be sure and check our answer. So, as the check, if we plug in negative 1/2 into there, we get 2 times negative 1/2 squared plus 9 times negative 1/2 plus 7. What is that? Well, negative 1/2 times negative 1/2 is 1/4 times 2 is 1/2 minus 9/2 plus 7. 1/2 minus 9/2 is 8/2, which is 4. So we have negative 4 plus 7. Negative 4 plus 7 is 3, and so that works. In a similar way, I'll leave it, because I've run out of room, to check that negative 4 is also a solution. So that's that problem. What about with part B? With part B, we can do a similar thing. Here, we already see we have 0 on this side, so let's go ahead and factor this side. We can factor out a 3x out of both sides, and so we have 2x minus 1 left over. And now that tells us that either 3x equals 0 or 2x minus 1 equals 0. Well, then what does that tell us? That tells us that either x equals 0 or take the 1 to the other side, divide both sides by 2, you get 1/2. As our check, we have 6 times 0 squared minus 3 times 0. That's 0 minus 0, which is 0, so that checks out. If we plug 1/2 in, minus 3 halves, 3 times 1/2. That gives us 6 times 1/4, which is going to be 6 over 4 is 3 halves, so we end up with 3 halves minus 3 halves, which is 0. So that checks out. All right. Now it's time for you to try an example. So go ahead and solve 2x squared minus 3x plus 1 equals 6 by factoring, and be sure to check your answers. So on the count of 3, I'll reveal the solution. 1, 2, 3. And there you have the solution. I made some mistakes with my signs. Yeah, always be careful with signs, as those can oftentimes mislead you. So, factoring is one method for solving quadratic equations. Another method for solving quadratic equations has to do with what's called extracting square roots. The basic idea here is to square root both sides, but the important thing when doing this is that we need to remember to add a plus or minus, okay? Because we're taking our own square root. So let's go ahead and solve each of these. Here, we're going to isolate, when we do this, whenever we see a perfect square, we're going to isolate that expression. So let's divide both sides by 4. When we divide both sides by 4, we get 3. Now we're going to take our own square root. When we take our own square root, we need to be careful to remember to add in the plus or minus. Okay? Let's check this. So checking this, we have 4 times plus or minus square root 3 equals 4 squared. Sorry, 4 equals 4 times here. The squaring, if I do square root of 3 times square root of 3, or negative square root of 3 times negative square root of 3, I end up with just square root of 3 quantity squared, which is 3, which 4 times 3 is 12. So that is correct. Over here, we do a similar thing. Here, the expression is already written as a perfect square. So we go ahead and take our own square root of both sides. When we do that, we get plus or minus 7 on this side. And thus, what we have is solving out, we have x equals, adding 3 to both sides, 3 plus or minus the square root of 7. We'll go ahead and just leave it there for now. But if you were to actually go through and check this, what you would have is the 3's would cancel out plugging back in. You'd have plus or minus square root of 7, square it, and you get 7. So that is the correct solution. Now it's time for you to try an example. So go ahead and solve each of the following equations by extracting square roots. Also be sure to check your answers. So on the count of 3, I'll reveal the answer. 1, 2, 3. So here you see the solution. Let me circle this real quick. So here you see the solution with the check. Here, be sure that you go through and recall how to simplify this radical. Now, with what we use with method 2, we can actually expand this into something called completing the square. The idea of completing the square is to turn a quadratic as sort of impartial quadratic of the form x squared plus bx into some sort of perfect square x plus d quantity squared by adding the correct c into here, okay? The problem here is to figure out what c is. We can do this by investigating what this looks like expanded out. X plus d squared equals x plus d times x plus d, which if we FOIL that out, we get x squared plus outer xd plus inner dx plus d squared. And then we notice that these terms are actually the same. So we have x squared plus 2dx plus d squared. And now we can figure out what we need to add by investigating this term. This would be our c, and this term corresponds to b. So we have that c should equal d squared. And what is d? Well, d we can find via this. So b equals 2d. In other words, D is equal to B over 2. So if we add in, add in C equals B over 2 squared. Okay? And that's how you get that magic factor. Another important thing to note here was that since we know D is equal to B over 2, we actually know what when we actually complete the square, we'll move backwards once we add that C there, and we actually know what that interior term is. It's always going to be B over 2. So now let's run an example now that we know how this works. So the way this works is first, we're going to go ahead and create our incomplete quadratic here. That's 2x, sorry. By taking our constant term to the other side, like so. Now we need to figure out what to add here. Well, we saw before, if you take b, this would be our b over 2 squared, that will create the perfect square. B over 2 is 2 over 2 squared, which equals 1 squared, which is 1. Now, so we claim we need to add a 1 here. Of course, we can't just add in anything we want. We need to do it to both sides. But we also saw before that whatever is on the inside, the b over 2, that's what creates the term on the inside of the perfect square, sort of moving backwards from what we did in the last slide. So that equals 7. Now we can go through and use our square root procedure. So x plus 1 equals plus or minus the square root of 7. Now we just need to take 1 to the other side. So x equals negative 1 plus or minus square root of 7. We definitely want to check this though. How to check? Well, let's go ahead and plug back in. Negative 1 plus or minus square root of 7 squared plus 2 times negative 1 plus or minus square root of 7 minus 6. What does that equal? Well, this, if we square that out, we end up with a negative, foiling this out, we'll have negative 1 times negative 1, which is 1. Negative 1 times the last term, first outer terms, negative 1 times root 7. So we'll have negative root 7, or plus or minus root 7. That will flip it, so it'll be minus plus root 7. The inner terms will be minus plus root 7. And the outer term the last term will be 7. Here we have minus 7 plus or minus 2 times root 7 minus 6. Now again, I wrote it minus plus here because now we know that these minuses correspond to this plus and so on and so forth. So all the minuses, all the tops correspond and all the bottoms correspond. So this, that, and that all cancel each other. And here we have 1 plus 7. The plus 7 and the minus 7 will, will cancel. Oh, that should be a 2, sorry. 2 times negative 1 is negative 2. The 7 minus 6 is negative 1 plus 1. Yeah. So 1 plus 7 is 8. 8 minus 2 is 6. 6 minus 6 is 0. So we actually get 0, and so it satisfies the equation. Now let's have you try an example. So go ahead and solve x squared minus 4x minus 1 equals 0 by completing the square. So on the count of 3, I'll reveal the answer. 1, 2, 3. Okay, and so again, you see here, just to briefly walk you through it, we add our 4 in, that's our magic factor because b divided by 2 squared gives us 4 in this case. We also see at the inside is our b over 2, which is the inside of this, which is negative 2. And then we go through and we do the square root procedure. And I also made sure and ran the check as well. An important fact about completing the square is that this is actually what's going to give us the quadratic equation in the next video. It does more for us though, also in regards to graphing, so it's worth getting familiar with. For more practice in in these first few methods for solving quadratics, be sure to look at page 856 and work problems number 4 and 25 through 46. In our next video, we'll finish off talking about quadratic equations.